All right, this video is going to cover the first of our two special cases with the Routh-Hurwitz table. So let's say, what if we have a 0 in our first column? Say g of s is equal to the numerator divided by, let's say, a fourth order polynomial for now. And we go through and we build our Routh-Hurwitz table. And let's say b1 or c1 is equal to 0. That could be problematic. Let's go with b1 for now. So let's see, why is that a problem for us? So if we calculate b1 equals to 0 here, what happens to c1's calculation? Well, c1 is the negative of that matrix that we have above, and it's got to be divided by b1 here, which is 0. We're dividing by a 0. That's a problem, right? So we have two options to deal with this, in this case, moving forward. Okay? So our first option, that one's just going to be to replace that 0 in the first row with a very small constant number, epsilon, we're going to represent it as. Epsilon can be positive or negative, it doesn't matter. From there, we're going to just continue as normal. That is our first option here. So if we have that Routh-Hurwitz table and we have that 0 where b1 was, we're going to replace it with an epsilon and continue our calculations for c1, d1, c2, all of those as normal here, right? So wherever that b1 was when it was 0, now it is just epsilon. Okay. The rules are normal from this point forward, right? We could choose epsilon to be a very small positive number or a very small negative number. It doesn't matter. Either way is okay. Right. Option number 2 is to take the polynomial that we had, that d of s, and we're going to take all the coefficients and put it in the exact opposite order and then do a Routh table for that. So essentially, we had a0 was all the way at the end. That was multiplied by s to the 0. a0 now goes with the highest order term, a1, a2, a3, a4, such and so forth there, right? So it's essentially writing our polynomial, same as before, but all the coefficients have been put in the reverse order here. So let's do an example for trying to figure out stability for a system that has a 0 in the first column of its Routh table. So let's go with a fifth order system here, s to the fifth plus 2s to the fourth plus 3s cubed plus 6s squared plus 5s plus 3. N is equal to 5. That's our highest order here. So we're going to have 6 rows and 3 columns as a result, right? So let's set up our table, and we could go through the same procedure that we've done before to figure out all the entries for this. But when we get to where b1 would be, we end up with a 0 here, right? And that's going to be a problem. It's specifically a 0 only in the first column. That's the one we care about. Okay, so for option number 1, we're going to replace that 0 with an epsilon, and we just continue forward as normal, just crunching it out as you would, just keeping epsilon in there, right? And epsilon is like a very, very, very small positive or negative number here, right? You can think of it as like 0.000001 or something like that, or a negative version of that, right? It's essentially 0, but just a little bit above or below 0. Right. So let's say epsilon is greater than 0, just a small amount. If we look at our first column, right, if epsilon is positive, we'll go first to second. That is our first row is positive, second row is positive, third row is positive. And then if we look at the math here for 6 epsilon minus 7 over epsilon here, that would actually end up being a negative number. And then the one after that would be positive. And then the 3 is obviously positive. We end up with 2 sign changes here, which means that we're unstable, right? What if we chose epsilon as negative here, right? Our first column would have the signs of plus, plus, epsilon is negative, so it would go negative there, then plus, plus, plus again, right? We'd still have 2 sign changes there for epsilon is negative 0.00001, right? So we end up with an unstable system either way, right, in this case. So generally, if we end up with a 0 in just the first column, we may end up with an unstable system. It's likely. Okay, let's go through our second option, right, which is to take that polynomial and just write it in the reverse order of its coefficients and then just do our Routh table as we normally would. 5 rows or 6 rows, 3 columns. Going through and doing the math is exactly as we always would, right? It's the same procedure as normal. And note that we only care about our first column, right? The other 2 don't matter. So if there are entries like towards the bottom right of the right column and the center column there, those values aren't going to actually factor into our first column at all. So they're not really going to matter at all, right? If we can look at this here, we see that the number of sign changes is equal to 2. We still end up with an unstable system here, right? So both of these methods work when we have a 0 in our first column here. And that covers our first special case.